Solar thermal. Solar thermal power conversion involves the use of sunlight to generate heat, which is then used to produce steam and drive a turbine connected to a generator for electricity generation. There are different types of solar thermal power systems, but one common approach is the use of concentrating solar power technologies. A working of a solar thermal power conversion. Here's a general overview of the working of a solar thermal power conversion system. Solar collectors. Large arrays of solar collectors, often mirrors or lenses, are used to concentrate sunlight onto a small area. These collectors focus sunlight onto a receiver or target. Ang kining solar collectors is mura ni sa examine nga mo-reflect sa siga at sa solar panel. Receiver. The receiver is a component that absorbs the concentrated sunlight and converts into heat. This can be achieved through various methods, such as heating a fluid, usually a heat transfer fluid like molten salt or oil, or directly heating a working fluid like air. Heat transfer fluid. If a heat transfer fluid is used, it circulates through the receiver, absorbing the solar heat. This fluid is then transported to a heat exchanger. Heat exchanger. The heat exchanger transfers the thermal energy from the heat transfer fluid to a working fluid, typically water, to generate steam. This process is similar to the operation of conventional steam power plant but with solar heat as the energy source. Steam generation. The working fluid or water is heated to produce steam. This steam is generated at high temperatures and pressures thanks to the concentrated solar energy. Turbine. The high pressure steam flows through a turbine, causing it to rotate. The turbine is connected to a generator. Generator. As the turbine rotates, it drives the generator, converting the mechanical energy from the rotating turbine into electrical energy. Condenser. After passing through the turbine, the steam is condensed back into water in a condenser. This completes the cycle and allows the water to be returned to the steam generator to be heated again.
The steam generation, ang tubig i-heat sa mahimong steam. Ang temperature o pressure sa steam mao magpatalijok sa turbine. Ang turbine ang mechanical energy sa turbine may mato sa generator, and convert ang sa generator ang mechanical energy to electrical energy. Ang condenser, i-condense niya ang katong steam nga generate tungod sa heat, i-condense niya into water para i-turn to steam na pod aron magamit og otro. Okay.
Cooling system. Some solar thermal power plants may require a cooling system to dissipate excess heat from the condensation process. This can be achieved through various methods, including water cooling or air cooling. Electricity transmission. The generated electricity is sent to a transformer and then to the electrical grid for distribution.
Ang cooling system mao na siya magpabugnaw og naay excess heat kanang palabi nga init nga pamagi nga ni tubig or hangin. Electricity transmission, generated nga electricity gikan sa generator iadto sa transformer para doon sa electrical grid aron para na distribute na. Mao ang solar thermal technology diagram.
Of solar thermal power conversion method. A solar thermal power conversion system typically consists of various components that work together to capture sunlight, convert into heat, and ultimately generate electricity. The main component of solar thermal power system include solar collectors. Solar collector are devices designed to capture and concentrate sunlight. There are different types of solar collector including parabolic throws, solar power towers, and parabolic dishes. Each each with a specific design of concentrating sunlight into a receiver. Receiver is the component where concentrated sunlight focused to absorb solar energy converts to heat. Gusto ko rin. Kani nga lang solar thermal, mao ko na siya mo convert sa init, kainit sa adlaw into electricity. Diyan na ni siya ikuan main component mo ni ang solar collector. Kani solar collector mo ni mo kuan sa kainit sa adlaw. Diyan kani receiver mo ni mo receive sa pusa. Kani receiver mo ni mo receive sa kainit sa adlaw. Diyan. Heat Heat transfer fluid. In a mini solar thermal power system, a heat transfer fluid is used to absorb solar heat into the receiver. Common heat transfer fluid include molten salt, oil, or the other specialized fluid. The fluid carries the heat to the next stage of the system. Heat exchanger. The heat exchanger transfers the thermal energy from heat transfer fluid to a working fluid. Typically, water to generate steam. The process is crucial to producing high temperature and high pressure steam needed to drive a turbine. Mas bagay. Steam generator. The steam generator produces steam from working fluid heated by the heat exchanger. This steam used to drive a turbine. Turbine. The turbine is a mechanical device connected to a generator as high pressure steam flows through turbine. It causes a turbine blades to rotate, converting kinetic energies into mechanical energy. Generator. Puso kalya. Ang kaning steam, mo ni mo kuan kanang mo pour sa turbine para mulihok. Ja kaning generator, kaning turbine, mo ni mo produce mechanical energy adaw sa generator. Ja kaning generator, mo ni say mo produce og kuan electricity. Condenser. After passing through the turbine, the steam is condensed back into liquid. Condenser this complete the cycle and condense water to return the steam generator reheating. Cooling system. Some solar thermal power plants are required to cooling system to dissipate excess heat from the condensation process. Water or air may be used for cooling depending on the specific design of the system. Ang kaning condenser, mo na mo condense sa steam para imong tubig. Ja, repeat ra gyud palang cycle. Ja, ang kaning kuan, kaning cooling system, mo na mo pa kuan sa excess nga heat, ipa cool nila nanay daw pamagyo sa tubig or hangin.
Tracking system. Solar thermal power plants obtain incorporated tracking system to follow the movement of the sun. This ensures that the solar collectors are always oriented to maximize sunlight capture throughout the day. Control system. Control system monitor and regulate various parameters such the position of the solar collector, temperature and pressure to optimize the performance and efficiency of the solar thermal power plants. Ang tracking system di ay mo ni siya mo sunod sa movement sa kung asa ang adlaw mo ni siya mo sunod movement ng tracking system.
General concept of solar thermal conversion system.
Types and application of the solar thermal power conversion method. There are several types of solar thermal power conversion methods, each with its own technology and application. The primary types of a solar thermal power system include parabolic through system. Technology parabolic through system use long convert mirror parabolic to concentrate sunlight into a receiver tube running along the running along the focal line. The receiver contains a heat transfer fluid typical oil which is heated and then used to generate steam for electricity production. Application: parabolic through system are commonly used for large-scale utility-grade electricity generation. They are sustainable for both centralized power plants and distributed.
Yan. Kata na po ko sa power tower systems. Ngayon.
Hindi na kanya pong solar. O di na explain. Hindi mo pong kami.
Dahil na ako na magiging nga ito. Saan na naman? Gigi.
Hindi na ta.
Dala. Oh no.
Solar power tower system. Technology: solar power tower system use an array of mirrors known as helu- helu- known as heliostats to reflect sunlight onto the central receiver tower. The receiver at the top of the tower contains a heat transfer fluid or molten salt which is used to generate steam for electricity production. Application: solar power tower are well suited for utility scale electricity generation. They are often deployed in areas with high direct sunlight, making them sustainable for regions with abundant solar resources. Parabolic dish system. Technology: parabolic dish system use a parabolic dish to concentrate sunlight onto a receiver at the focal point. The receiver typically contains a Stirling engine which contains I convert the thermal energy into mechanical energy, driving a generator. Application: parabolic dish system are vers- versatile and can be used for both centralized power generation and distributed applications such as providing power to remote location or serving as a backup power source.
Linear Fresnel reflectors. Technology. Linear Fresnel reflectors use flat mirrors to concentrate sunlight into a linear receiver. The receiver may contain a heat transfer fluid or be a part of a direct steam generation system. Applications. Linear Fresnel reflectors are suitable for both large-scale power plants and smaller distributed applications. They are often used in regions with high direct sunlight. Solar dish engine systems. Technology. Solar dish engine systems use a parabolic dish to concentrate sunlight on the receiver, usually a Stirling engine or a Brayton cycle engine, to generate mechanical power. Applications. These systems are suitable for both centralized power generation and smaller applications such as residential or community power systems. Direct steam generation systems. Technology. In direct steam generation systems, sunlight is used to directly heat a working fluid, often water, to generate steam for electricity production. The applications. Direct steam generation is commonly used in various solar thermal power technologies, including parabolic throws and linear Fresnel reflectors. It is applicable for large-scale power plants. Isa. Solar Integrated Combined Cycle or SICC systems. Technology. SICC systems integrate solar thermal power components with a conventional gas or steam turbine combined cycle power plant. Applications. SICC systems enhance the efficiency of conventional power plants by supplementing them with solar thermal energy. They are often used in hybrid power plants to provide dispatchable and reliable power. These types of solar thermal power conversion methods are applied in various settings, including utility-scale power plants, distributed generation, industrial process heating, and remote power applications. The choice of technology depends on factors such as location, resource availability, scale of power generation, and the specific application requirements.